unimpressed joke.
Okay. Okay. I'll take that. So what I thought we'd do today is look at some of these homework questions. What's that doing there? Go away. Excuse me while I open and close various windows. Okay, we got it now. We did an awful lot of stuff yesterday, a lot of information to collect. It's kind of hard to, keep it all in check. The homework questions are basically, here's a story, pick one of these 5 answers. And I think the easiest way for me to do this is actually to keep the answer there, and then I can talk about the answers and why they chose that one. So the first question, question 1A, that hopefully you're all looking at. Can you see this? Make sure we're in the right place. Can you see question 1 in the screen? Okay. A teacher wants to determine how class attendance during the term affects the grades. And in particular, affects the grades on the final exam. And then it says in question A, describe how the data would be collected if she was doing what's called a prospective observational study. Well, she would record the records of attendance throughout the term. So basically, week 1 attendance, week 2 attendance, week 3, all the way to the end, and she would collect it. The word prospective is talking about it hasn't happened yet. This is what she is going to do as the future progresses, right? If you did it a different way, if she did it, for instance, a retrospective way, at the end of the term, the teacher would ask the students to remember and report their attendance data. I don't think I would do it that way, but could you imagine that a better way, in my opinion, a better way of doing that would be, couldn't you look at last quarter's classes and look at their attendance and their final grade? Right, she's already got that data, right? It happened last year. That would be a better example, in my opinion, of a retrospective. One of the reasons I'm showing you the answers to these questions is that sometimes you'll read them and they're not great questions, but I can't change them, right? So I want you to just look at their answers and see what they have. Now, it says give one disadvantage of collecting the first one. Well, the first method was that she took the data in, right, throughout the term. And one disadvantage, the student's behavior might be altered if they found out the teacher is keeping attendance records. That problem, if you want to call it a problem, because it might make them come more often, it's not necessarily, is that if you affect the data as you're collecting it, then it's biased in some way. Suppose I'm collecting data on broken windows in a abandoned high-rise flat, and I wanted to keep how many broken windows each day for about a month. If I went there and walked around and looked at broken windows and was writing it down on the piece of paper, might that affect how many windows get broken if somebody notices that somebody's keeping track of broken windows? Because they might think, oh, they're trying to find out who's doing it. Maybe I shouldn't break them anymore, right? I don't know if that's a good analogy, but can you see recording something can actually have an effect on your data? There is actually a theory is called, I believe it's called the broken window theory. And it's to do with inner cities. And they've discovered that the best way to try and keep inner cities as nice as possible is to fix broken windows as soon as they happen. Because if you let one broken window go for a couple of weeks, more get broken. The same thing is true about garbage collection. Collecting garbage and don't leave it on the streets as quickly as you can tends to reduce the amount of garbage that the street generates. It sounds strange, but that's what it does. Can you see that if you record, if you were recording that information but not doing anything about it, or if you did something about it, you might alter it. And so we've discovered that. If you ask students at the end to remember their attendance, would you agree that most students, let's do high school students, have the ability to overestimate their attendance? Let's be generous. Jimmy, how many days were you missing last semester? Oh, probably only about 2. Now, it might have been 20, but aren't they likely to say 2 anyway? So you can't guarantee, honestly. But that kind of question, really, there's lots of choices. So you have to just go through each one as they do. Now, the yes, no ones are easy. You'd get one and then you pick the other. So I don't mind you seeing the answer to this. Students whose undergraduate was economics were followed for 10 years after graduation to study the number of different jobs that they took. Decide whether the following term applies to this observational study. Right, you just collected data, right? You didn't force it. Is this a retrospective study? No. Isn't this the other version? Right? Prospective, right? And there's another one, I'll skip by that one. A medical researcher wants to know how lifetime sun exposure affects the risk of skin cancer for people who are over 50 years old. Decide how you might collect this data from a retrospective case study control. So it uses the retrospective and this term case study. Well, you gather a sample of people over 50 who have skin cancer and a sample of 50 people over 50 who do not have skin cancer, and then you collect data on how much sun they were exposed to, I guess. Now, can you see why that's retrospective, right? You've already, I mean, they've got cancer or they don't, and they're over 50 and you're picking them. That to me, I'm just thinking of problems with that data. Give me a problem with collecting good version of that data, right? So you went to California and you randomly found 50 people at skin cancer, and you kind of said to them, on average, how many days were you out in the sunshine, right? Let's suppose that's a number, you know, how many hours in a day on average were you out? And that's the number that you were using to detect exposure to the sun. Can you see anything that might be difficult to get good data based on that way of analyzing things?
The location of each individual when they were exposed. Somebody exposed, say, in Florida is going to have a different exposure rating to somebody in Washington or Canada.
Right, and up a mountain probably different than in a valley, and by the seas probably different in the middle, and north in Washington's not the same as south in California. Yeah, that the number of hours exposed is probably not a good measurement. I think that would be a major issue.
Especially if they're using what they recollect.
Yeah, people's memory is not great. Couldn't you also, I mean, I'm just off the top of my head, using sun lotion and not using it, couldn't that be just as big an effect?
You can ask what type of job they had, like if they worked outdoors or indoors.
Yeah. So I think the bottom line here is that it's going to be really difficult to get good data. Would you agree? There are just so many unknowns, right? Where were they? What did they use? You know, did they recollect it correctly? Did they use sunscreen a lot? Because I bet you could get twins. This is a classic one. Get twins who live in the same place with the same job and they stayed in the same area, right? So everything else is the same. And one of them, because they liked it, used a lot of suntan lotion, and the other one didn't. If you had lots of twins that did that, and you found out that the ones who weren't wearing the suntan lotion got a higher incidence of skin cancer, wouldn't that be a very good evidence that the sun is causing the skin cancer? Because right now we're assuming that that's the case, and I'm sure it is, but that's the kind of cool way that you have to look at stuff. Now, Reuters reported on a study published in the Journal of American Medical Association, and a little reference to it, in which researchers recruited 276 volunteers in the age range 18 to 55, and they used nose drops to infect them with a cold virus. Is that legal? Are you allowed to give people the cold?
Unethical at best.
Definitely unethical, but evidently it seems to have been done because they've got a reference to it. Okay. Can I click on that? Oh yeah, 1997, volume 277, pages 1940 to 1944. So evidently in 1997, they got some volunteers, gave them a couple of $100 and said, we're going to give you the cold. Or a couple of $1,000, whatever they paid them. I'm assuming they paid them. They then answered questions about their social lives. Oh, I missed a bit there. The volunteers were then quarantined and observed to see whether they came down with a cold or an infection. So not only did you give them a cold, you stuck them in a room for a fortnight. I'm assuming maybe your own room. They then answered a number of questions about their social life, including the number of different types of contact they had. Okay, so they stayed in their own home. Family, work, community, blah, blah, blah. Reuters reported that those with 1 to 3 types of social contact were 4.2 times more likely to come down with the cold symptom compared to those with 6 or more contacts. And that is counterintuitive to me. Right? The more people that you had contact with, the less you got the cold. God, how would that work?
It's possible because you're exposed to more people that you might have had more immunity to the strain of cold that they gave you.
I like it. That makes sense. Yes. Isn't that classic? The human immune system. The more you're exposed to, as long as you don't have other problems, don't you get good immunity to all sorts of things? Yeah. True story. When I started teaching, which was in August of 1980, for the first 3 years, I must have caught every cold, flu, and whatever you could mention, plague, I don't know what I caught. I caught some horrible things, right? And then my immune system was pretty sturdy because I caught most stuff at least once. And so my natural immunity got better. And so after that horrendous first years teaching health-wise, I was pretty good. Getting a bit old now, so when you get old, your immune system's not as good. But when I was in my peak, you could have gave me the plague and I would have shook it off. That's how good my immune system was. It was fighting fit. And so, yeah, if you want to get healthy, no, that's a bad word. If you want to have a good immune system, mix with lots of people who've got diseases, because eventually your immune system will be very good if it doesn't kill you. Now, the asking here what was the explanatory and what was the response. In that story, wasn't the explanatory variable the number of contacts that they had? And the response variable was, did they catch the cold? And the researchers in this study took an unusual step to help reduce the impact of confounding variables. Explain what they did and why it might have helped to reduce impact. Well, they had this thing where they quarantined the participants, so the isolation might have helped reduce the amount of outside factors contributing to whether they became sick or not. I'm not convinced by that, but it's the best argument they've got. There are a lot of possible factors for why mixing with more people is actually better for you. But Who knows? Here's a very straightforward question. Explain why it's preferable, whenever it's possible, to do a randomized experiment rather than observational. And there's your reason. Because you have control, right, of who gets what, right? The people are random, right? The two groups are very similar to each other. You have so much control, you tend to get much better results. That's why experiments are always preferred rather than observational. And there's here's an interesting one. A headline in a major newspaper read, breastfed youth, so when you were a baby, you were breastfed, do better in school. So SAT test, whatever it is. Now, this study was probably based on observational or randomized. What do you think it was?
Observational.
I'm pretty sure you can't tell mums to breastfeed their baby and tell other mums not to, right? It ain't going to happen, right? Oh, why am I doing that? You can see the answer, of course, sorry. I observe whether the baby breastfed or not. Okay, that one's a little bit different. That one you can do on your own. I think I'm going to take off the key now for a little while. And we'll go down to question 9. In a study on workers' productivity done in 1927, well, that's probably not very modern, it was observed that the productivity improved when the lighting was increased. However, it was observed that the productivity also improved when the lighting was decreased. What term is used to describe the fact that the productivity increased simply because the workers knew they were in an experiment? Okay, so you got workers doing their, you know, the kind of thing where you turn 2 screws and then you clip it and you pass it on, turn 2 screws, clip it, right? That kind of mundane job. When the lights went up, they worked quicker. And when the lights went down, they didn't work quite as quick. And the explanation of why that might be the case, it's not to do with the lighting. It's to do with, it could have been the lighting, but couldn't it also be when the lighting went up, the person thinking, oh, they're watching me, I better move a bit quicker now. My boss can see me. And when the lighting went down, oh, well, they can't see me, so I can go a little bit slower now, right? Which one of those guys are we doing? Well, let's do it by process elimination. It's not the placebo effect, isn't that for pills and things? A double-blind experiment and a single-blind experiment, those two terms don't belong in this story anyway, right? Remember, double-blind, you don't know what's happening. Well, they can tell the lights are going on and off, so that's not going to happen. Simpson's paradox and the Hawthorne effect are the one of these two guys. We've never covered either of those terms. Does anybody want to have a guess?
I'm gonna guess the Hawthorne effect.
I like your guess. So let's go up and put it back on and see if I'm telling the truth or not. There you go. Oh, if you want to know what Simpson's paradox is, let me tell you what Simpson's paradox is. There's lots of terms that you get in statistics, and you really, you know, I can't cover everyone because I forget half them as well. But I can tell you about Simpson's paradox. It's a really weird property, right? I'm going to pretend that I'm collecting data on 2 hospitals. And we're going to make life very simple. These hospitals only conduct 2 types of operation, right? And so the 2 types of operations, right? So there's 2 hospitals. I'll call this hospital A, and I'll call this one hospital B. And the two types of operation, I'm going to call them a simple operation and a dangerous operation. And the number that we're going to use to decide how good a hospital is the death rate. So the death rate is how many patients die when they go to this hospital and receive an operation, right? How many die per 1,000 patients, right? Now, in the simple operation, let's say you had 10,000 people, and the number of people who died there was 2. Right? Very few people die if you go in to get stitches on your finger, right? A couple die because bad things happen, right? Now, the dangerous one is like triple, quadruple heart surgery, right? Something really dangerous. And this hospital only did 100 of those, but 99 of them died. But when you combine this data, there was 10,100 patients and only 101 died. So I'm going to do a quick calculation and tell you what percentage that is. And it's 1%. So hospital A can advertise that if you come to our hospital, there is a 1% chance that you're going to die in the operation. Now let's look at hospital B. Hospital B does 1,000 operations, right, of the simple type, and 1 person died. They also do 1,000 of these ones, and yeah, 1 died. Now, if we do that one, it's 2 out of 1,100. And I might change one of my numbers to get Simpson's paradox. Yeah, okay. Let's up this to 19, see if that makes a difference. Now, this hospital, more people die as a percentage of, patients compared to this hospital. If you were going to go to a hospital for an operation, do you want to go to this hospital for a triple bypass?
Why is
You're probably going to die.
why is it 1,100?
Oh. Now it's 1,100. Can you see that Simpson's paradox, basically it says you have to be careful when you combine data, because if you combine data, don't you lose a lot of the nuances? In this hospital here, it might be better to take the simple operation, right? But shouldn't you go to this hospital if you're doing the dangerous operation? So don't both of them have strengths and weaknesses? Yeah, if you only use this number, you could end up thinking this hospital is always better than this one. But you could either they're better at different things. But that's an example of Simpson's paradox. And they discovered that that gets done a lot when people want to screw with your head and data. How could I do that? Suppose I had a school, suppose there was 2 schools, and one of the schools only allowed the best calculus students to take the SAT test, and the other school let everybody take the SAT test. Could you imagine that the first school might come back with really high scores and the second school not so high scores? But isn't that not a true reflection on how good the schools are? Isn't that more a reflection on who was picked to do the test? So you got to make sure that when you're comparing 2 hospitals or 2 anythings, that you're comparing like with like. It's not helpful if there's 2 things being measured or more than 2. It's a dangerous exercise. If I was a kind of suspicious person, wouldn't you imagine politicians doing exactly this technique of picking things in a certain way to reflect what they want to be true? For instance, can't you say that oil prices have not gone up everywhere? Has gasoline prices gone up in Washington state? Yes. Now, it might be that gas prices haven't gone up in Texas because the oil's there and it's straight to the door, right? And it doesn't require much trucking, right? But isn't the truth that oil prices have gone up? But picking one place and say, well, it hasn't gone up here, so it's not going up everywhere, so it's not really going up at all, is unfair, in my opinion. Right. Back to this fellow. An investigator believes that the new medication will help to reduce anxiety and that a placebo will not. Of course it shouldn't. In a single blind study, patients are blind to the treatment, right? They don't know which pill they're getting. One pill is going to help them reduce anxiety. The other pill, the placebo pill, is no active ingredient, right? It's a sugar pill. The result is that the group taking the new medication had reduced anxiety, while the placebo group did not. And then it goes on and say, explain how the experimenter effect may have played a role in this result. And this is their answer. The person evaluating the patient may have treated patients differently depending on how they did their medication. Now, I've already done that idea before. If it's the doctor collecting information, if he knows you've got the sugar pill, isn't he going to kind of indirectly, or even direct, I guess, but more likely indirectly, ask you in a tone because he knows you're not being helped? How is your anxiety? Is there any real difference between last week? But if he knew you're getting a pill and he believed that that pill is going to help things, he might phrase it like, you feeling a bit better this time? Are things better? And, you know, how's your anxiety? A little bit less? You know, the way you can ask people because of what you believe is happening. That would be an example of that. That's why we do double blind. Doesn't the doctor not know either? So when he gets the feedback, it's uncorrupted. Okay, this better be a pretend story. An experiment on elephants in captivity was done to find out whether breeding would occur more often when the elephants were kept together in a herd or when a male was isolated with a female. Explain how ecological validity affects the ability to generalize these results to wild elements. Elephants, they behave different in captivity than they do in the wild. So you can't go to a zoo and watch how an animal behaves and then say, oh, that's probably how the same animal will behave in the wild, because isn't it in a cage or at least a big pack and there's no lions going to try and eat you, and all sorts of other factors come into play. And so the way that animals behave, I'll give you an example. A lot of wild cats show signs of anxiety in zoos. One of the signs that they use is pacing. They pace up and down all the time. That is not a natural behavior for a lion or a tiger. And that's caused by the environment they're in. Now, if people were watching that, they'd say, oh, well, animals, wild tigers and things, one of the things they like to do is pace up and down looking for prey. That's not how they do it. Don't they try and sneak up on you quick? They don't like march up and down. That's what's going on there, I think.
Professor,
Yes.
we're only seeing the paper, not the screen.
Oh, I apologize. I switched over and forgot to switch back. Thank you. Well, you read the story, or you heard the story. So here's a retrospective study. It was done of 517 veterans who never smoked, was done to determine whether there's an association between lung disease and exposure to workplace gases like dust and fumes. In this study, veterans were asked whether or not they remember being exposed to gases, dust or fumes in the workplace. A concern expressed by the investigator was that patients who had histories of lung disease may be more likely to recall a history of exposure, whether accurate or not. That subject reported in Good Health did. Discuss whether the following is likely to be a problem. Yeah, if you don't have good memory on something, asking them questions about what happened to you in the past is very difficult. Right? If you're really healthy and you don't remember coughing or anything, aren't you probably not going to remember, oh, that was that funny gas when I worked in the garage and, you know, I used to cough my lungs up every time it passed through. It's not good data, unfortunately. And there's a confounding variable. And there's not blind. Okay. If you were going to do an experiment, if you were going to collect data, here is a little list of the best to the worst. The best kind of data you're going to collect is experimental data. Right? So you're going to collect at least a group, split them into two. Of the experimental data, double blind is the ultimate goal. If you can find a way of doing a double blind experiment, anything you get out of it is going to be really good data. Single blind, and then essentially no blind. Right. Double blind would be a new drug, right? One lot gets a placebo, one lot gets a new drug. Doctor doesn't know who's getting what. Patient doesn't know whether he's got it. You record the data at the end. If there's any significant difference between the two groups, the pill's doing a great job. Single blind. Typically, that would be the patient doesn't know what they're getting, right? They get a pill, they don't know. But the doctor who's recording the information does know. And that can have an effect. And we had a story today about it. No blind would be, you had two groups. You can't always hide the experiment. Give an example. Suppose you were going to do a new form of physiotherapy for people who'd seriously broken one of their legs, right? Old physiotherapy, new physiotherapy. Would you agree that the person who's getting the physiotherapy would know what kind of physiotherapy they were getting, right? You can't hide that, right? Would you also agree that the person giving that physiotherapy knew that they were getting that physical therapy because they're the ones that are doing it, right? So you can't hide anything in those cases. And sometimes you can't do that, right? You just have to do that. That's kind of the order of best to worst. Now you've got observational. And observational, oops, get them in the right order. Why is prospective typically better than retrospective? Why do you tend to get better data when you do a prospective study than a
Because-
retrospective?
Because you can gather it all at once.
And you're gathering it fresh, right, as it's happening. Aren't retrospective studies plagued with the 20 years ago, how many times were you out in the sun per hour, right? Or can you remember how many colds you had? You know, a lot of that data it can be based on people's memory of what's going on. Now, it's not all that way. Some retrospective studies collect data. Do you know the most classic way of collecting it? It's kind of sad, but it's done this way. You find out what someone has already died of, and then you get their medical records, and you can trace incidents in their medical life that may have led up to that, whatever they died of. And sometimes you can get pretty good data from that. For instance, do you know there's a lot of data out here about high cholesterol level and heart attacks? Have you heard anything about high cholesterol levels and heart attacks? Do you know that used to be much stronger evidence than it is today? Because what they've found is that not all cholesterol are the same. Don't they have some cholesterol that's not that bad and some other kinds of cholesterol that are really bad? And so that they had to refine their information. All of that data is coming from retrospective studies, essentially, right? People who died of heart attack and then they try to collect information on it. You could do it with prospective, but then you have to wait for them to die, don't you? And that can take a while. So, worst till best.